Welcome back, everybody. Hopefully everyone is healthy and well. We're now going to conduct a hypothesis test for an unknown population mean, assuming that the standard deviation of the population is unknown. For this is going to be a lower tail t-test. Okay. This is how it reads. The Bureau of Labor Statistics reported that in May of 2009, the mean annual earnings of all family practitioners in the United States was $168,550. A random sample of 55 family practitioners in Missouri that month had mean earnings of $154,590 with a standard deviation of $42,750. Do the data provide sufficient evidence to conclude that the mean salary for family practitioners in Missouri is less than the national average? Test at the 1% level of significance and show all 5 steps. So, step number 1 is establishing your hypotheses. And the hypotheses that we're going to establish are going to be possible by reading this last sentence. It says, do the data provide sufficient evidence to conclude that the mean salary for family practitioners in Missouri is less than? So that's going to be our alternative hypothesis statement, which says that the mean population mean income or mean salary is less than the national average. And the national average is 168,550. So therefore, the null hypothesis statement is saying that the mean uh, annual salary is equal to 168,550. And we're going to test at 1%, so that's going to be our level of significance, alpha, 0.01, or our probability of committing a type 1 error. And that occurs if we reject the null hypothesis that is true. So far, we haven't seen that happen in any of these examples. All right, but I have a feeling that this one is going to have us do that. Step number 3 is computing the test statistic value. And of course, the formula is this T formula, where we take the sample mean and subtract off the purported population mean under the null statement and divide it by the estimated standard error of the sampling distribution. So, what is our sample mean here? Well, it says a random sample of 55 family practitioners in Missouri that month had a mean earning of 154,590. That's going to be X bar, 154,590. Then we're going to subtract off the purported mean salary under the null hypothesis for the population, which is 168,550. We'll take that difference and we're going to divide it by the standard error. Notice the standard deviation of our sample is 42,750. We're going to divide that by the square root of the sample size, and the sample size is 55, as 55 practitioners were randomly surveyed. When you dial this up on your calculator, you should compute a test statistic value of about negative 2.422. Step number 4 is establishing a rejection and acceptance region. And this is a lower tail test because our alternative hypothesis is a less than symbol. And our alternative hypothesis statement, again, happens to be the claim. It is the hunch or the belief of these researchers. We're hoping that sample evidence is going to enable us to reject the null hypothesis and opt for the alternative hypothesis as being the truthful statement. Okay, and we'll see if we're able to do that. We'll see if the claim is being supported by sample evidence. This is a lower tail test, so the rejection region is going to be found only in the lower tail of the student t probability distribution. And the size of that lower tail rejection region is going to be equal to the level of significance we set back in step number 2, which is to say it has a size of 0.01. To find this critical t value, we're going to have to use our inverse t function on our calculator again. And the area to the left of this critical t value is going to be 0.01. And we're going to have how many degrees of freedom? Well, it's always your sample size minus 1 degrees of freedom for this particular continuous probability distribution. Sample size was 55, so the degrees of freedom is going to be 55 minus 1, or 54 degrees of freedom. You type that in, and approximately you're going to get about negative 2.403. Again, this value, the value you get on your calculator after using this function may be different than this, a little bit different, but as long as it's ballparkish, don't worry about it, as usually our tests are very conclusive one way or another, and a little bit of round off error is not going to sway our decision one iota. Now, ladies and gentlemen, we're ready to make a conclusion regarding our test. All we have to do is go back to our test statistic, which is negative 2.422, and ask ourselves, where does it fall? Does it fall in the rejection region or the acceptance region? Well, the cutoff value, the critical t-value that separates the lower tail rejection region from the rest of the curve, which is the do not reject the null hypothesis region, is negative 2.403. And notice that negative 2.422 is a little smaller or less than negative 2.403. So in this case, our test statistic falls in the rejection region. And since our test statistic falls in the rejection region, we are going to reject the null hypothesis, and we are going to go with the alternative hypothesis as being the truthful statement. So it does appear that sample evidence is supporting the claim of these researchers. So our conclusion would be sample evidence is strong enough to support the claim that the mean weight of all one-year-old boys, I'm sorry, I'm thinking of a different problem, support the claim that the mean annual salary for family practitioners is indeed less than $168,550. And ladies and gentlemen, we only stand a 1% chance of committing a type 1 error, of actually rejecting a null hypothesis, which could still maybe, in fact, be a true statement. And notice that would be a very bad thing to reject a statement that is truthful. Okay? But 1% chance of committing that type 1 error is not a large level of risk. And so this is a very conclusive test. So I would have faith, without a doubt, in rejecting the null hypothesis and supporting the claim that yes, it looks like the mean annual salary of all family practitioners is indeed less than $168,550, and that's supported by formal hypothesis testing and our sample evidence from the sample that was extracted from the parent population. So that concludes this lower tail test, illustrating the critical value method for conducting a t-test.